7 questions, 24 points. One construction from yesterday. I already warned you what it's going to be. It's going to be one of the 4 from homework, which is going to be tough for some of you because you got to actually try it. One of the 4 from homework or the midpoint one from yesterday's notes. I'm telling you what's there. It's either you're going to practice it on your own or you're not. Okay? So one of these 4 or the midpoint one. That's the one construction for tomorrow. Vocab, here we go. Collinear. If I give you a diagram tomorrow and say, name 3 points that are collinear, what are you looking for? 3 points that do what? All on the same line. What if I ask for lines or points that are coplanar? All on the same plane. All of them have to be. All of them. If I give you 4 points and say, are these 4 points coplanar? 3 of them are, the other one's not. The answer is no. All 4 must be. Naming a plane. How do I name a plane? 2 different ways to name a plane tomorrow. Capital letter in the corner, or what about 3 points? 3 points that don't form a line. You can name a plane. Correct. Draw your own diagram. Take your notes out. Open up to page 5 for me, please. Take your notes. Open up to page 5 so you know exactly what I mean by draw your own diagram given facts. Look at problem number 4. That's exactly what I'm talking about. I'll give you a set of directions. Draw me it. All right, so that's exactly what I'm talking about there. Question 4 with draw a diagram given facts. Algebra with segments. I think we have done a ton of these in your homework. Here you go. This is the example I used from last class. What's the value of x? Okay, you got to set up your own equation, solve it, and get after it. Okay, so that's what I'm talking about, algebra with segments. Okay. And then finally, I think about half this quiz is on midpoint and distance. Know your formulas because I'm not going to provide it. And I'm warning, I'm telling you, hey, I want to make sure ears are open here. The distance formula problem will be simplest radical form. Leave your answers in simplest radical form. So if it comes out to be radical 32, we got to be prepared to change that tomorrow. All right, we got to be able to simplify that. Anything we want to touch on real quick before I get to today's notes? Tomorrow, you walk in the door, there's your quiz. I don't take questions. All right, when do I take questions? Right now or after school? That's when you ask questions. All right, I don't take them as you walk in. Yep.
Are we allowed to use our calculator?
Yes, absolutely. Yep. Any test or quiz we take this year, calculators. Make sure you bring your compass and straight edge too. Anything you want me to go over now? Because time's up when you walk in tomorrow. Or unless you're staying after and want to review anything with me individually. We're all good for tomorrow. First chance to show me what you got. And that's exactly what's on there. Notice what's not on there. Did I put nets on there? Don't study them. Don't waste. I'm not going to waste your time. I'm always going to be upfront and honest with you. This is what's on the quiz. There's no net question on there. I'll wait till the unit test to do that too. This is exactly what's on the quiz. Don't study any extra. All right? Questions? All right, let's roll. We're going into the new stuff. This new stuff, not on the quiz. All right, this new stuff, not on the quiz. Homework due Friday. I'm not checking anything tomorrow. Homework due Friday. Not checking tomorrow. We've got all day to take the quiz. If you finish early, you can start the homework, but I'm not teaching anything tomorrow, not looking at anything. All right, we're going to start talking about angles today. Segments, lines, they were beautiful, but we're going to talk about angles. Before we do that, we need to understand how an angle is made up of. An angle is made up of two of these bad boys called a ray. Little quiz review. A line has what at the ends of them? Arrows. Line segments have what? Points. Well, a ray's got one of each. A ray starts at an end point, and then it's got the arrow at the end. So we're going to call this A. We'll call that point B. And we'll call that point C. When you wrote a line, what did you make? You made a smaller line. When you guys wrote a segment, what'd you do? Smaller segment. So guess what the symbol is for ray? Okay, smaller ray. But here's the change up. In array, order matters. Line, you can name it any way you want. Points, A, B, B, A, doesn't matter. This though, no. Array has to start with whatever the endpoint is. Whatever the endpoint is, that's how your array's got to be named. After that, I don't care, any point on the array. So you want to name it AB, array AC, array ABC, your call. But it's got to start with the endpoint. Okay, got to start with the endpoint. Questions? So array CA wouldn't cut it for this diagram. It's got to be A followed by something. All right, when I put two rays together, it's called opposite rays. Opposite rays. Two rays share the same endpoint. Let me give you a diagram first. It's much easier to talk about it with the diagram. Let's throw R, S, and T on here. All right, there's a bunch of rays in my diagram. There's a bunch of rays, but there's only one pair of opposite rays. One pair of opposite. They have to share the same endpoint and go off in different directions. So ray blank and ray blank are opposite. What do we think here? Name two opposite rays. They have to share the same endpoint, go off in different directions. Here we go. Let me put the 2-8 up there. Hey, let's hear from 16 first today. We're named two opposite rays. There you go. Now many people get it on the first try, SR and ST. Does everybody see they share S and they're going opposite directions? A couple people always give me RT and RS. That's the same ray. Okay, that's the same ray. RS and RT. They're not going opposite. It's the same ray. All right, all good. All right, now what happens when I put two rays together now? Here's where we're talking about today. Here's where we're living. Angle. That's called an angle. So let's draw ourselves an angle. Two rays meet. Where two rays meet. Let's put A right here on one ray. Let's call it where they meet, point B. And can we stop saying where they meet? That has a special name where they meet. Vertex. That is where the two rays meet of an angle is called the vertex. And C on the other one. And let's plop a little small number 2 in the inside of the angle. All right, when you're writing this now, how do I write angle, right? I don't want to write A-N-G-L-E every time, or never. So what do I use for an angle symbol? One of two things. I could use that. That's angle. And sometimes you may see me do an arc through it. Depends on how I'm feeling every day, how I roll. All right, so either one, with or without the arc, that's an angle symbol. All right, naming an angle. 3 different ways to name an angle. You're going to see I prefer one over the other 3, or the other 2. First one is name it with this vertex. What's the vertex of this angle? B. So I could simply just call this angle. This is angle B, everyone. Hello. This is angle B. Very rare, but sometimes you could get a lowercase letter or a number inside. You could also name it that way. So this could also be called angle B or angle 2. That's rare, but I still want you to see it. It's rare, but I want you to see it. Here's the way I love to name an angle, and I'll show you why after we name it. This is the way I like to name it. 3 letters, middle letters, the vertex. 3 letters, middle letters, the vertex. So how could I name it using this method? Let's hear from 13. Angle, 3 letters, middle letters, the vertex. ABC, yep. I could also name it CBA. That's fine. Why do I like this one over the other 2? Do not draw this. And I say to you guys, hey, angle B. Anybody have a question for me? If I just say angle B. Which one? Which one? Anybody see? There's multiple angle B's that have a vertex, right? Are you talking about this one, the original one we had? Or how about this one I just drew? Or how about the whole thing? Those are all angle B. All right, so you can never go wrong if you name it with 3 letters. Okay, name it with 3 letters, please. Because if you name it with 1, you're playing with fire that there might be more than just one angle. Questions? All right, let's roll. Types of angles. I probably should fly by this. I'm not even too sure why I keep talking about this. Probably for the right angle. I probably keep talking about it. What do you guys know about a right angle? Measures? 90 degrees. Done. The only thing really I'm the most important thing to me here is I'm not going to write the number 90 in an angle. Oh, no. I'm not writing 90 degrees. So what are you going to see instead to know it's a right angle? The little box, right? There you go. That's 90 degrees. I'm never going to write the number 90 in there. We're going to use the symbol. How about a straight angle? Measures 180. Can anybody give me a different vocabulary term we've talked about this year that's basically the same as it is the same as a straight angle? A? A line. That's it, right? A line. A line measures. It's a straight. A line is a straight angle. Okay, a line measures 180. There you go. From here to here, there's the angle, 180 degrees. What do you know about an acute angle? A lot of people say less than 90, but now that you're getting into the high school math, I'm going to just give a little more detail to it. Next year, when you go to Algebra 2, if you make it, you're going to start talking about negative. Too harsh, some of you. It's home. It's home, the truth. Sorry. You're going to start talking about negative angles next year. So instead of saying just less than 90, I'm going to say between 0 degrees and 90 degrees. Because there is such things as negative degree measures. But you don't have to worry about that this year. And how about obtuse? Between 90 and 180, yes. Because, yes, you could have something bigger than 180 next year. All right, I figured most of you guys were aware of all that, which is good. What are 2 line segments congruent? Line segments. We got a quiz tomorrow. When they have the same lengths. When they have the same lengths. Well, when are 2 angles congruent? When they have the same angle measure. So what I'd like you to do below is quickly draw 2 angles that look like they have the same angle measure. When we had 2 line segments, we didn't know the actual measures of them, but we knew they were congruent because what did they have on them? Hash marks. Same thing for angles, but we don't use hash marks. Okay, if I don't know the actual degree measures, but I know they're congruent, you'll see these on them. You'll see arc marks on them. Okay, you'll see these now. That's basically the equivalent of hash marks for angles. Okay, that they're congruent to each other. All right, ready to make a congruent angle using your compass and straight edge. Here we go. So here's a new construction, not on the quiz tomorrow, but new one. Just so you know what we're doing, we're going to take angle A, copy it onto point B. First step, grab your straight edge. I need a ray coming from B. I need a ray to do this construction on. So everyone give me a ray coming from endpoint B. So hopefully at the end, we have another ray coming here that looks, and the 2 angles are congruent to each other. First step, put your compass on the vertex A. Put your compass on vertex A, everybody. And you're going to make an arc with your pencil through the two rays. Make an arc with your pencil through the two rays. Keep your compass right, keep it the same opening. All right, go over to endpoint B now. Go over to endpoint B. So you guys just made an arc through, go over to endpoint B. And you're going to make an arc through the ray. That's the same length as you did on angle A. That's all I've done right now. Made an arc through angle A and made an arc through this ray here. So we make sure we're all good. We're not playing catch up here. Do you see 2 points of intersection right now on the rays that you made? Mark them for me. Just make them points so you know where they are. Label those 2 points of intersection right now that you just created. And now put your compass points on there. You're basically measuring, using your compass, measuring the opening between the 2 points of intersection. So put your compass pencil and point on there. You don't need to make any markings. You're just using your compass to open it up that length. Okay, ready? Finishing touches. We're going to come back over to the ray, but we are not going to put our point on B. We are going to put our compass point on where that arc intersected the ray. That's the huge thing you got to remember about this. The final step is putting your compass point on the intersection of the ray, not the end point. And now you are going to make an arc that intersected the previous one. Make an arc that intersected the previous one. And once you do that, you guys are pretty much, I think, know the deal now. Grab a straight edge, line it up with your end point and the point of intersection, and you got yourself a congruent angle. Anybody that walks in this door right now, how can you tell they're congruent? How can you show them they're congruent if they don't know the constructions? I can now put the arc marks. Yep. Now watch what I tend to do. I tend to put 2 arc marks. No, not arrows. 2 arc marks, just so it doesn't look like a construction line. If you want to settle with 1, that's fine. I just don't. If I do 1, it kind of looks like it's a construction mark, which it's not. And then remember what I told you yesterday, leave all your constructions, leave all your arc marks, okay? All right, before we move on, I'm not confident yet, and you got plenty of white space, it looks, as I look around your packets. Draw yourself another angle somewhere on that page and copy it. Just draw an angle right now. Draw a ray to the top, bottom, left, right of it, and let me see you copy your angle you just drew. Classroom, because let's face it, I know my expectations are high in here, but I also understand that I've thrown already a lot of constructions at you, which means a lot of steps. And sometimes you can forget the steps easily, especially when you're home. You're like, oh boy, I know I did the first arc, but where do I go from here? All right, so there's no excuses now that you can't do it. Up on Classroom, under Unit 1, we have a little tab that's construction help. Myself, Miss Linehan, who's downstairs, who's the other honors geometry teacher, created a YouTube page of all the constructions we're going to do throughout the year. Don't get intimidated, because again, this is all the ones we're going to do throughout the year. So you're home one night and you're stuck. You can't remember copy and angle steps. So you go through all our videos and you find copy and angle. And it is exactly like how you're taught in class. All right, after the videos, because obviously I guess we're important and we need ads. And it's just like the way we did in class. Okay, so that is on Classroom. That is a resource for you. So you don't come in the next day and, oh, I didn't know this. I forgot the steps. No, baloney. You didn't forget the steps. You just didn't go on and take a look at the videos. All right. So that's on there for you for the entire year, no matter what construction and what part of the year we're in. All right, we're all good? All right, put your compass and straight edge to this side. We're done for the day with that. I got one more vocabulary term. So we know about angles now, right? We know how to label them. We know how to name them. Last vocabulary term. Bisector. Bisector. Hey, cut something in half. Could be a line segment. In this case, we're going to talk about cutting an angle in half. An angle bisector cuts the angle in half and forms two congruent angles on each side. Talk to me in geometry right now. What is this right here? What's that saying right there, that symbol? Okay. Ray AX. Bisects. Cuts it in half. What angle does it cut in half? BAC. So everyone go ahead and draw Ray AX. Draw Ray AX. Like it's cutting BAC in half. So A is the vertex. Ray, I know it has an arrow at the end. And since it's Ray AX, X has to be somewhere on here. Tell me something now. Tell me a true statement now about my diagram. This is where I'm going to have you guys go soon. Next unit. Ooh, boy. It's going to knock your socks off. I'm telling you it bisects. So now I want you to give me a true conclusion right now. What's true about my diagram? Max?
Ray AX and angle BAC are congruent.
A ray and an angle can't be congruent. Two angles can be congruent. Two segments can be congruent. But a ray cannot be congruent to anything because it goes on forever. Okay? Here we go. Let's open it up. I got to do a better job of this, hearing from different people. Here you go. 13. What's true about my diagram?
Angle ABX is
Hold on. ABX is not an angle. Right? Watch. ABX. That's not an angle. But give me an angle. Go ahead. I think you just got to name it differently. XAB. Now, hey, if you guys are struggling with angles, literally take your index finger and trace it and figure out the letters. XAB. All right, keep going. XAB. Yep, I'm listening. Are what? There you go. Congruent. Perfect. Because that's a bisector. What can I put on my diagram now to show that? Let's hear from 14. What can I put on my diagram to show those two angles are congruent? Arc marks, correct. Right here, and try to offset them so it doesn't look like one full one. So bisector cuts it into two congruent parts. Two congruent parts. Questions before we throw algebra now at you, using a bisector. All right, let's do it. Some algebra. In this course, never skip over the directions, because there's probably something important in the directions that's going to lead you to being these answers correct. Okay, KJ and KL are opposite. Okay, that's good. Here's what we need to remember. KN bisects LKM. Mark your diagram with something. Mark your diagram with something. Right away. Get in the habit. Oh, I see a new vocabulary term. Bisects. Mark your diagram. KN, Ray KN, identify it. Bisects, trace it with your index finger. LKM. LKM getting bisected. What did you just put on your diagram? 20, what did you just put on your diagram? Where? Name the angles you put them on.
NKL and NKM.
There you go. Those two angles are congruent. Definition of a bisector. Everyone see why it's those two? All right, you ready for the algebra part now? Now let's go to example 1. LKM. Find that angle right now. Trace it with your finger, however you get it done. L to K to M. L to K to M. That whole angle here is 7x minus 5. However you want to label that. I'll just do this so you know I'm talking about the full angle. Okay, that full angle is 7x minus 5. NKM, find it, find it. NKM, 3x plus 9. Find. And if anybody's wondering what this little m here, that means measure. Meaning, hey, give me a degree measure, please. Because a lot of kids think they're cute and funny. Oh, you want the measure of LKM? It's 7x minus 5. We're done. No. Find me the degree measure. Degree measure. All right, your show now. I need somebody's got to set up an equation for me to solve for x here, right? I need x equals this number. Based on all the info you have right now, can you come up with an equation that we can solve for x? Dig deep. Dig deep. Oh, there it is, right in front of me. 4, when you're ready. Got an equation to solve?
7x minus 5 equals 3x plus 9.
So you're saying this big one and that small. You're telling me this big one is the same measure as that small one there, right?
7x minus 5 minus 3x.
Okay, I don't hear an equals in there though. I don't hear an equal. Ready? Here we go. What do you know about, what do these two markings mean? So if that's 3x plus 9, how are you labeling the other one? What?
It's 3x plus 9.
I put those two together, what do I get? Okay, a yes, but it's also equal to, how big is the angle when I put them together? Okay, so everyone see what we're doing here. I'm taking the two 3x plus 9s, adding them together, and I know it's equal to the bigger one, 7x minus 5. Okay, those two congruent angles add up to the bigger one. Go ahead, solve for x. We're not done yet. I'm not done calling out people yet. Let's solve for x. Take your time. 17, when you're ready, let me know your x value. Take your time.
$23.
23, got it. Thank you. Good job. You're fine. Bad habit in here. Bad habit. Oh, I found x. Everyone clap for me. Feel good. I'm moving on to the next problem. No, you're not. X doesn't make you a winner in here. It helps you get to the final answer, but am I done here yet? No, I need 23 and plug it in to LKM, which is 7x minus 5. So you're not done when you find x. So 7 times 23 minus 5. When you're ready, 12. What's the measure of LKM? What is it? 106? 56. There you go. Yep. Bonus. What type of angle is that? Oh, obtuse. We got that one. All right. We still have time for one more here. Say same set of directions, new angles. So don't remove your congruent marks. I'm just doing a new set of angles now. Those two angles still congruent. All right, ready? Let's label it. NKL. Everyone find it. N to K to L. N to K to L is 7x minus 9. J to K to M. Find it. JKM. Trace it. x plus 3. I'm looking for the measure of JKN. JKN, that angle there. This is a little bit tougher. Even some of you studs out there might have trouble with this one. Well, right away, hey, anybody see another angle I can label 7x minus 9? The one? MKN, right? Because these two are congruent. If that's 7x minus 9, that's 7x minus 9. How can I use all of this now to set up an equation? This is tough. Tough to see. You don't want to do 7x minus 9 equals 7x minus 9. You're not going nowhere with that one. What can I do, though? Anybody see anything? Name, go ahead. Sorry. Claire, go ahead.
You can do x plus 3 plus 7x minus 9 equals, or wait.
Yeah, it doesn't equal anything here, right? Can't set it equal to anything. I thought you were going in the right direction. Name?
Kyle.
Kyle, go ahead.
X plus 3 plus 7x minus 9 plus 7x minus 9 equals 180.
Where do you get the 180 from? Go ahead.
That's how it measures. Or that's how LKJ measures.
I add up all three. Don't I get this straight line? And what do we talk about straight angles today? They equal 180. There's your equation. Great job. X plus 3 plus 7x minus 9 plus the 7x minus 9. I put all of them together. I get a straight angle that's worth 180 degrees. Go ahead. You're on your own to finish this up for end of class. Find x, plug it back in to find JKN. Yep, that one was a tough one. Equals 180. Forms a straight line. As you're finishing that up, finish it up, finish it up. As you're finishing it, reminder that homework on the next page is due Friday. Quiz only tomorrow. Quiz only.
Other calculator is 13.
Was this one 98? When you plug it in, is that what it was? When you plug in X, 90, 86? It should have been an obtuse angle. Okay, we'll finish this during Friday's notes. Should be an obtuse angle you end up getting.